Must TCP use IP? Is it true that TCP is short for TCP/IP and they mean the same thing? Is it possible for TCP to be built on top of another protocol besides IP?
TCP and IP, v4 and v6, are definitely separable, and one does not imply the other, as proved by the example of TCP over IPX, RFC 1791. However, TCP cannot be built over just any network protocol. 2 reasons. There is no segment size field in the TCP header, only the data offset, which gives the size of the TCP header. Therefore, TCP will work only with a lower layer protocol that includes enough information to calculate the size of the TCP segment, i.e., the payload size of the lower layer protocol. That assumption is true for IP4, RFC 791, IP6, RFC 2460, and IPX, RFC 1791. But not true in general, for example, not for avian carriers, RFC 1149, see Note A. TCP is only designed to work over a connectionless network protocol. TCP effectively does not work over certain connection-oriented network protocols, for example, the ATM constant bitrate service, because the 2 fighting rate control functions lead to very poor or unpredictable performance. Another degenerate example is TCP over a TCP tunnel. The TCP specification, RFC 793, is not a good source to decide this question, because it admits that it leaves its interface with the lower layer largely unspecified. Note A, for TCP to reassemble datagrams printed on little sheets of paper, whether carried by pigeons or a more intelligent Corbett network, the size of the payload would have to be written in a standard location. Alternatively, an adaptation layer could heuristically determine the segment size. The optical scanner used in the implementation of the host stack of the avian carrier spec, RFC 1149, included such an heuristic adaptation layer, but it remains undocumented.
I haven't read the whole RFC, but the language in section 1.4 seems to suggest that any lower-level protocol can be used. The interface between TCP and lower-level protocol is essentially unspecified except that it is assumed there is a mechanism whereby the 2 levels can asynchronously pass information to each other. Typically, one expects the lower-level protocol to specify this interface. TCP is designed to work in a very general environment of interconnected networks. The lower-level protocol, which is assumed throughout this document, is the Internet Protocol.
Internet Protocol Suite. TCP is not short for TCP/IP. TCP/IP is often used as a shorthand way of saying the Internet Protocol Suite and usually includes other standard protocols. When people say TCP/IP, they are usually including UDP over IP, in which UDP is used instead of TCP, and a great many other protocols such as ARP, IPN, DNS, SNMP and other application layer protocols. Application layer. Applications use application layer protocols such as SMTP for email. These sit on one of 2 transport layer protocols, TCP and UDP. A few application layer protocols will use either or both of UDP and TCP, but most are used with only one transport layer protocol. Transport layer. TCP and UDP are 2 transport layer protocols used in the Internet Protocol Suite. If there are others, I don't know of them, and any others would represent a vanishingly small specialist use. Others transport layer protocols have been defined, their usage probably represents only a small proportion of global IP traffic. Internetwork layer. Whilst it might be theoretically possible to use TCP over something other than IP, in practice TCP is always used over IP, the Internet Protocol. IP moves packets between networks. Think of IP as connecting multiple LANs together. Network interface layer. Ethernet is just the most popular family of low-level link layer protocols on which TCP/IP is carried, but TCP/IP is also widely used over ATM and others. Appendix 1, a note on transport layer protocols. The only transport layer protocols in significant use on networks that use the Internet Protocol Suite are TCP and UDP. Note also this statement in Google's FAQ for their Quick protocol. Why didn't you build a whole new protocol, rather than using UDP? Middle boxes on the internet today will generally block traffic unless it is TCP or UDP traffic. My emphasis.
The reason why TCP/IP is such a common abbreviation, as opposed to, say, UDP/IP or SCTP/IP, is because the two protocols were designed together, and in the original paper by Vint Cerf and Bob Kahn, the two concepts were combined together into a single protocol. Soon thereafter they were divided into IP to provide routing and TCP to provide flow control, multiplexing, error detection, etc. It wasn't until 6 years later that UDP was introduced to provide a lightweight multiplexing layer without the rest of the overhead involved with TCP. Still, TCP and IP are two separate things and completely and intentionally independent. The fact that TCP does not require IP is immediately apparent with the fact that TCP can run unmodified on both IP4 and IP6, which are two completely different protocols. With a little work, you could create a competing protocol to IP that would serve the same purposes, but it would probably have to contain most if not all of the same features, and would probably end up looking a lot like IP anyway. You could argue that extensions to IP, such as IPsec, are effectively alternate layer 3 protocols, so there you go.